Hi friends, so welcome to Machine Learning Journey. This is lecture 8 of our uh, machine learning series at beginner level, Introduction to Linear Regressions. So in this lecture, mainly we will discuss about linear regression algorithm, where it is used and what in what kind of data it can be used and what exactly does it mean about a linear and what does it means when we say regression. So in the previous lecture, I have explained about the regression task or like types of supervised learning, regression and classification. So in the regression task, the output is always number or continuous. It's like it can be anything from some fixed given range A to B, or it can be from minus infinity to infinity, depending on the nature of output. But it is a continuous. And in classification, there are some fixed categories. For example, if you are using class trying to classify images, it can be cat or dog, or some colors, some size of a t-shirts, or like that. So that kind of task is known as classification, but here we are talking about linear regressions. So what does this linear means? So let's say you have a data set which I have previously used. The same data set I will use so that you can better connect. So you have hours study and marks you got or a student got. So when he studied for 2 hours, he got 40 marks. When he studied for 4 hours, he got 60 marks. When he studied for 6 hours, he get 80 marks. Now, what is my task is I want you to predict if he study for 5 hours. What you will do? uh, you will first try to visualize this data maybe, or you will assume that there is some relation in input and output. So how many variables are there? There are two variables. One is input and one is output. So you assume that this output is known as y and the input is x. So there is a some relation between x and y. What kind of relation it exists? Maybe it is y equals to some constant c and x square. Maybe y equals to c root x, something something, same constant, and some additional value you need to add, let's say b. So it can be anything, but you don't know what relation it could be. So let's say you first assume that uh, the relation is linear. So for the linear, you assume that y equals to x plus c. Now you don't you know that you have some pairs of x and y. For given x, what is the value of y? Now with that, can you figure out the m and c value? In the schooling, you have studied about the linear equations. So solving the linear equations in two variables, in three variables. So in the two variables, what you do is you have one variable y and you have one variable x, and it is a relationship between these two variables, which is denoted by m and c, where m is a slope and c is the intercept at y-axis, correct? So in the childhood, you have studied this. Now in the same thing, if I say instead of given m and c, you don't know m and c, but you have so many values of or pairs of x and y. With that pairs of x and y, can you figure out m and c? This is my task. So in the machine learning, whatever the data is given, let's say this data is given, and when you are try to visualize this data, it is like 4 hours, 6 hours, the 20, 40, and 60. If you visualize this data, it will be a linear. So all the dots are connected or passing through a linear equation. So this line represents our data. For this given x, this is x and y. For this given x, there is a corresponding value y, which you want to predict. So this line, if you are able to bring this line from the data with some algorithm, then you are done. You are ready with your model. So in this kind of data, when the data is linearly correlated between input and output, in that situation, you will use linear regression. Since the output is continuous numbers, so you use linear regression. We will also study about logistic regression in some other lecture. But as of now, you understand that the given data, the inputs and outputs are correlated in a linear form, which fits in the some linear equations. That's why you assume that this problem can be solved with linear regression algorithm. In linear regression algorithm, you have two variables x and y, which are like input and output. You already know you have pairs, and you assume that there is a some weight w, or let's say we assume that m only. M is a variable which you don't know the value, and c. So with the pair of x and y which is given to you, you figure out what is the value of m and c with some algorithm. What kind of algorithm? With gradient descent, you might have heard about differentiation and calculating loss functions and all these things. You might have heard, but if you have not heard, no issues. Just assume that, just remember that you have a given data. You don't know what is the relationship between x and y. So you assume that if if it is a linear, then I will assume that m and c and x, and you will assume that this is the equation which will fit in this data, and you try to calculate m and c, and then you test on the unseen data. Let's say it is a training data. You have, let's say, 100 samples. 100 cross how much? 2, x and y. Let's say you have 3 samples which is not present here. 3 cross 2, x and y. Let's say 30 cross 2. 30 samples are there for your testing. So after this 30 samples, if it can predict the correct y, how many, if it is predicting 28 correct answers, then your model is performing well, because this x and y, this pairs, which is a test data, it has not seen before, but it is performing well. So our assumption for this given data x and y, it is correct that it is a linearly fitted. If our, let's say we train the model, and now we have some value m and c. Let's say m is 10 and c is some 20, and then we have equation, so 20. So this is our model actually. The value, these are the weights. Okay, two weights, and the two weights model, and these are the values we calculated using some algorithm like gradient descents and all cost functions and all these things. How we got, we will discuss, but let's say we got this values. Now you test on the test set, and you assume you got that only 2 out of 30 is correct. Then you are clear that on the training data it is okay, it is able to somehow correlate with the training data. But when I give some unseen data which is not known to the model, it is not able to predict the correct answer. It means we have just created a memorized versions of our data. It is not generic. Machine learning, what is all about? Machine learning is like all about, you have a given data, you create some algorithm or model, let's say you create some model which can be useful to predict on unseen data. That's all the purpose of machine learning, all the basis of this AI, machine learning, everything. So in that situation, if it is more than like so many answers are wrong in the test set, then the assumption is the linear equation is not fitting our data. So there might be some other equation. Let's say y equals to m x square. Maybe you need to square the variables and then you need to multiply, or some other relation will be there, quadratic relation, some other relation might be there. So like this, linear regression works. Now the linear regression, there are only two variables, x and y. So let's say if the inputs depends on the multiple variables, so how you will write? Y equals to, which is a prediction, w1 x1 plus w2 x2 plus w3 x3 dot wn xn plus b. So what is this w1 w2? W1 w2 nothing but it is a weights, and the b is biased value. Biased value in the sense, what additional value you need to add after calculating the dependency of each input variable, and then you add some value so that you can get a correct answer. It can be avoided also, but just to adjust the overall equation. For example, you have some, you predicted that this is the equation I am getting. So at value x equals to 0, you have some value. So this can be adjusted using this biased value. That's why we has bias. If it is passing through origin, eventually after our calculation, b will become almost 0. So how many variable medal parameters are there? N plus 1. N are the weights for each coefficient, and b is the intercept. So n plus 1 variables are there. How many input features are there? N input features or n input variables. This can be a house price prediction where you have so many inputs, for example, bedrooms, area, what kind of location it is, uh, what kind of cost of living it is, like different input features. And overall with that features, you need to predict the output y. And we are assuming that it is linearly correlated. This data is linearly correlated between each other. In the next lecture, we will understand about more about like cost functions and all, how to calculate these values exactly. But in this lecture, we have understood about if we visualize the data and it shows some signals about the fitting into a linear equations, then we can assume that we can try with a linear regression algorithm and check whether it is performing well. In machine learning, most of the things are experimental. So you need to check whether this algorithm will works or not, and which algorithm should check first. It will be depends on your knowledge and your intuition, and this knowledge will come with experience. Okay, thanks a lot. We'll meet in the next lecture.